So let's talk about the slope or the gradient of a line. There's different ways of finding it. I guess the first way we saw it was we simply said rise over run. So vertical rise over horizontal run. So here we go. There's a line. Let's call it L for line. There's 0.55 and another 0.21. We came up with a formula. So the rise is the difference in the y values, the run's the difference in the x values. But in this case, it is important we have the same order, because we're not squaring this one. Not like the distance formula we squared, so it didn't matter, but here it matters. So whichever one you choose first has got to be first for both of them. And which one did I go first? I used the 5s. So I've got 5 minus 1 over 5 minus 2. We get a slope of 4/3. Then there is another way which is often forgotten. Here's another line, capital L. If you happen to know the angle it makes with the x-axis, but it's always got to go to the positive side, so it's always going on the right-hand side, then the slope of that will be the tan of that angle. Because if you imagine a right-angle triangle there, so there's the axes, you've got a right-angle triangle, rise over run is opposite over adjacent, tan. So you can use that. And so for our one there, if I'm saying that's 120 degrees, then it's minus root 3 would be the slope of that line. Slope 1, I could work out that angle now, because we worked out the slope was 4/3. Simple little trig equation to solve. And so that angle must be 53 degrees. So some rules. And no, I have not spelt if incorrectly, by the way. So two lines are parallel if they have the same slope. We are aware or not aware of the double F if. When if is spelt with a double F, it actually means if and only if. Now when that comes to theorems, it means the theorem reads both ways. So two lines are parallel if they have the same slope. So if you know they have the same slope, you can conclude they are parallel. But it goes the other way as well. If you know they're parallel, then you can conclude they have the same slope. So not every theorem works like that. So ones that do, we say if and only if. So I double F. Slope 1 would equal slope 2. Perpendicular, the slopes are the negative inverse of each other, or the easy way of saying that is they multiply together to give -1. So M1 times M2 would be -1. Okay, A, B, C and D are these particular points. We just don't know what A is. We want to work out what A is if they're parallel. Well, we now know that if they're parallel, they have the same slope. So slope AB I can work out. It's 2. Slope CD, I don't know what A is, so best I can do is say 2 over A minus 3, but they're parallel. So they've got to have the same slope. So let's solve that little equation. And we get A is 4. Remember, you're presenting your solution to someone. It's not for you, it's for someone else. Explain what you're doing. Why are you solving this? And that was my opening statement there. Oh, well, if they're parallel, then I know the slopes are the same. What about if they're perpendicular? Well, in that case, I know the slopes must multiply together to give -1. So let's solve that little equation. And we get A is -1. Here's one of the ones that we looked at with using Cartesian geometry as well as Euclidean geometry. We've been given 3 vertices of a parallelogram. We've got to find the 4th one. Now when you name the parallelogram, remember the order is important because you go around in cyclic order. So if I plot, there we go, the 3 that they gave me. Now where do I put D? Well, I've got to go in that order. A, B, C, D. It means D must be, whoop, there we are, down there. I could do a lot of work or I can do a little bit of work. The way I could do a lot of work, well, I could find out the slope of AB, because this is a parallelogram, that would also be the slope of CD. I've got a point, I've got a slope, I could find the equation of that line. I could find the slope of BC, it would be the same as the slope of AD. I've got a point, I've got a slope, I could find the equation of that line. Then I could solve them simultaneously and find the point of intersection. That's the way of doing it with a lot of work. Just using the fact that they're parallel, I can do it with a little work. Because to get from B to A, I go across 3 and down 5. Well, because they're parallel, then that must be the same going from C to D. So all I've got to do is go 3 across, 5 down. Where am I? I'm at the point 0, -10. And there's the answer. heck of a lot quicker than doing it all the other way. So if I use the geometry to help solve the problem, I can save myself a lot of time. If you want to prove 3 points are collinear, so together, linear, on a line, so together on the same line, how would I do it? Oh, I'd just pick 2 of the points. Let's say I picked A and B. I'd find that slope. Then I'd pick another pair, A and C. It could have been B and C, it doesn't really matter. If those slopes are the same, we know the lines are parallel. However, they both contain the point A. So they can't be parallel, therefore they must be the same line, because they've both got A. So that's how I would go and prove it. I'd find the 2 slopes and say, aha, but they have a common point. Therefore, they've got to be collinear. All right, there's the first bit of theory for today, just talking about slope.